Hi, Miss Sparks.
Hey, Emily, how are you?
I'm good. How are you?
Good. Did you want to go over the original 8.2 worksheet or the 8.5 worksheet that had some of the reviews on it?
I think it was the 8.2 one and the
And the
one
review?
mixed. Yeah.
Okay. All right. I have both of them pulled up, but I pulled the 8.2 up first. Let me show you what the 8.2. Can you see it? Okay.
Yes, yes.
Okay. Um, this is the 8.5, and it had, obviously the hyperbolas that we were going over.
Uh-huh.
And then that here were and I'll go ahead and erase all of that and we'll redo it. But these were all of the parabolas.
All right. I think I get everything else. It's just like the parabolas are kind of like confusing for some reason.
Yeah, a lot of people, it just was a little confusing on the 4P and the P and
Yeah.
all of that because we're so used to finding the vertex and the axis of symmetry and all that. This was new.
Yeah.
So just trying to get it clarified.
Yeah.
Do you want to start at this worksheet
That's
then?
fine. Yeah.
And let me see one other thing. Let me move down. Yeah, there was one other one over here. This number 17 had to do with parabolas too. So let me go ahead
Okay.
and erase that. And there was, because other than that, there was only two.
Okay.
There was the two parabolas that you had to graph, and then this. So.
Yeah. So Miss Stone sent me an email and she said that since I wasn't in class on the other day, she said my test is going to be a little bit different, but she said to still bring all of my assignments and stuff.
Right.
Like, okay.
Yeah. And yeah, because I had one absent too. So she and I are trying to figure that out.
Okay.
Of what that's what it's going to look like because the test was unusual. I don't know if you heard that or not.
I did.
Okay. So we're trying to figure out what to do with the ones that were absent because there are hard workers like you and a couple of others that were legit sick, but then there were others, I don't know. We're kind of praying about how to handle it.
Okay.
But the other thing I found when I was going through the test was the wording on two of the questions was not very good, and that needed to be fixed also.
Okay.
So all of that will help.
All right.
All right. Oh Lord, this is I'm having a lot of trouble, and I hate to do this to you, but I'm having a lot of trouble with Cami here recently. So, which is what I write on.
I was like, what's that?
It's what I write on. It's how I bring the PDFs up in
I see.
MATLAB. And I don't know. It's locking up a lot. And so I might have to at various times reload the worksheet.
You're
So I
fine.
apologize for that.
It's fine.
But okay, so number 9 on the review, that's where we'll start.
Okay.
So these were pretty easy and pretty straightforward. And I do something kind of weird because this is it's easier for me when I'm trying to find the focus and the directrix on a parabola to have the squared variable on the left.
Okay.
So I will rewrite this equation. This is what I would do if it were me.
Okay.
Okay. I would rewrite it like that. And let me explain why. Because when you're trying to find the focus and the directrix, you're going to want it in there's a vertex format and there's a transformational format. And believe it or not, this is the x squared on the left-hand side is a transformational format. And this it is where it looks like this. This is the standard equation transformational format when the center is 0, 0, or the origin for all parabolas.
Okay.
Okay. And so the reason why for me, I like to write it, I would rewrite the equation into where the x squared variables on the left is because then it looks familiar to me because this is what it looks like for all parabolas. Does that make sense?
Yeah, it does.
Okay. So now that I've rewritten this, I'm just going to go ahead and line up the standard form, which is the x squared equals 4py. And I'm going to put my equation that I was given underneath it. And I'm hoping that you'll see a familiar, like it will look a little familiar to you. The only difference between this one and this one is this 4p right here. Would you agree?
Yeah.
Okay. So what is the understood coefficient in front of the y on this one?
A 1.
Yes, ma'am. So I would put the 1 there. And now if x squared equals 4py, and that's the standard equation used for every parabola, which has been proven or derived by mathematicians, then it would stand to reason if x squared equals 1y, then with everything else being constant, I could actually set 4p equal to 1. Does that make sense to you?
Yeah, I guess so. I think so. Yeah.
Okay, because basically this matches this and this matches this.
Yeah,
So if I canceled those out, the only thing I have left is 4p and 1.
Yeah, that makes sense.
So what I'm essentially saying is that 4p equals 1.
Okay.
Because this one right here is always true.
Yes.
Okay. So now what I'm going to do in order to find my focus and my directrix is I'm going to solve for P because P tells me what the focus and the directrix are. And in order to solve for P, I have to divide both sides by 4. And now P equals 1/4.
Okay, that makes sense.
Okay, it does?
Yes.
Praise the Lord. And I think we didn't lock up. Yay. So if P equals 4, and I know that my x squared is the squared variable, because the other thing that we know about parabolas is they can either open vertically or they can open horizontally. And the squared variable tells us which direction they open. If the squared is on the x, then it opens vertically. If the squared variable is on the y, it opens horizontally. So this is just a standard good old parabola like you were used to from Algebra 1, where the origin is at 0, 0, because we promised you all that's all we would give you. And with a standard parabola, 1, 1, and -1, 1, and 2, 4, and -2, 4 are always on those, just because of the squared.
Yeah.
So now the focus, but you can also use your graphing calculator. So the focus is when it's an x squared, the focus is going to be in the y coordinate. So
how did you get the little, why did you mark the points at 4 and then at like on the graph?
oh, okay. Well, if
I'm confused.
okay. If I put a 1 in for x, 1 squared is 1. I mean, I guess this is kind of bad because it's a parent graph. I about have these memorized. But like I said, you could plug this into your graphing calculator. But if I plug a 1 in for x, if I square 1, I get 1.
Okay.
If I put a -1 for x and I square it, I still get 1. If I put in a 2 for x, I would get 4. And if I put a -2 in for x, I still get 4. So that's how I know those points.
Okay.
But
For some reason,
like
I don't remember doing that in Miss Stone's. Did she do something different? Maybe I have no idea.
you know what? She actually did.
Oh,
Um, and I remember her telling me that now.
the, oh, the simulitis.
Yes.
That's what it was. Oh, oh, that makes sense.
Yes. And I do think it's easier.
Okay. Oops.
And I forgot totally about that. When it's a parent graph, because I about have it memorized, I always default back to this. But yes, she did do something different.
Okay.
I'm very sorry
Oh,
about
no,
that.
no, you're fine. I forgot. So,
No, but I mean I should have remembered because I did try to make a note of that in case any of y'all asked that question.
you're fine.
And
So,
basically that's the distance um, between the points.
yeah, so it's like I have written on the my paper, it's like the absolute value of 2 times p, maybe?
Yes, that's it.
Okay.
Exactly.
So would you do 2 times 1/4?
Yes, ma'am.
Okay. So that, wait. Uh, that, so that's like 1/2. Is that right?
Yes. But it goes for the different points. Let me hang on just a second. Let me pull my notes back up.
Okay.
And maybe that will help. Because I added that to
Trying to
because and I think we did do that on the on the mixed review we didn't really have to do it on because they were the parent graphs and like I said,
because it's just x and y.
yes.
Ugh. How do you find the focus with, do you add p? Is that
Well, the focus, that's that when you're solving for P, and that is your focus. When it's the 1/4 is your focus, and you would find that by
oh, my dog's barking.
yeah, that's okay. I'll probably have mine bark before long. But so we found it here, it's 1/4. And so the focus is 0, 1/4. And then the directrix is in the opposite direction. So it's going to be y equals -1/4 because it runs perpendicular to the axis of symmetry. And in this case, the axis of symmetry is the y-axis.
Okay. So,
But that's how you found the focus is solving for P because P is the focus essentially.
okay.
But it's a coordinate of the focus, and so it's determined by whichever variable is squared. So in this case, it was the x that was squared, so the focus is going to be in the y coordinate.
Okay.
If the y was squared, then the focus would be in the x coordinate.
Okay, I think that
because what the best way to remember it is that the focus or the directrix is going to run perpendicularly to the axis of symmetry. And so because you know that the directrix runs perpendicular to the axis of symmetry, which is whatever splits the parabola in half. So you know that it's going to be y equals -1/4 in this case. So that's a little bit easier to determine, like, and so you can determine that then the y variable, the y coordinate will be the focus.
Okay. So, okay. Hold on, I have to move my computer.
Okay.
Thank you for helping her.
Oh, no problem. I'm
My
happy.
mom. Okay. All right. So, how do you find Miss Stone was saying stuff about, like, she said, like, the axis of symmetry is the variable that stays the same. Does that mean anything?
Yes, it does, because what you're looking at is the x, the x variable would stay absolutely the same all the way down. This is the axis of symmetry in this case. It's literally the y,
Okay.
it's the y axis, because the x variable stays the same. So that's where, how you know that that focus is going to be 0, 1/4, because your focus is always on the axis of symmetry somewhere. And the directrix runs perpendicular to it.
Okay.
It's kind of difficult on the review, because the unfortunate part is we don't really have some real numbers to work
Yeah, I
with.
know. That's why, like, I don't know.
So I feel like maybe when we get to the other 8.2, unless you've already got them all filled out, I don't know, maybe it'll help some. I'm hoping.
Okay.
I'm wishing we had some real numbers.
I do too.
But maybe what I'll do is I'll just try to go in while we're here and create some worksheets for us, and I'll just make one up so that you'll have some, and you would just have to hand graph them, if that's okay with you.
Okay. I'm still trying to figure out how you got your parabola for the. I don't know why it's.
Okay.
1/4. Wait.
Now my focus, which I can't even graph very well on here, would be, let me use a different color.
Okay.
My focus is going to be like just above the origin, because it's 0, 1, 4.
Yeah.
And the axis, the directrix is this one, and it's y equals -1/4. So they're actually right separate from each other.
Okay. And then to make the parabola, you do the simulitis. So it would be. Why am I having trouble figuring this out? So don't you go like a half from the focus on the right and then half from the focus on the left?
Yes. And those would be 2 points on there. Okay. But then you can keep moving it, up.
Oh, I see.
You see what I'm saying? Those would be 2 points. Like 1/2 would be on each side. She's doing that because you're just finding 2 points. And I found multiple points, which that probably is what's confusing.
Okay.
And she did this. You could take 2 times the square root. This is 2 times p, and the absolute value of it is going to be 1/2, because it's 2/4, which reduces to 1/2.
Yeah.
Which you would go here. It's very teeny tiny.
Okay, I see now.
And there, and because it only takes 3 points to graph a parabola. And now we have the vertex and 2 additional points. But to me, that didn't really give you too much of a parabola. Okay. So I just went back to defaulting to the good old T-chart that we learned way back in Algebra 1, because it gave me some greater direction, and it's really easy on the parent graph. Because if I plug in a 1 to the equation, 1 squared is 1. If I plug in a -1, it's still 1. If I plug in, to me, those are just easy. It's not like I'm having to work with big numbers. Does that make sense?
Yeah, it does.
And I totally forgot that she taught you all how to do that, which that's like with bigger numbers. Wow, that's just so much easier.
Okay. Yeah. Because I was like, what? How did you get like the 4 points? I was like, what? That makes
Um,
sense now. Okay.
Yeah, I'm so sorry.
You're fine.
I totally forgot that she did that. And to me, when it's a parent graph, I kind of default to old methods
Yeah.
because those points are so easy.
Yeah.
But one of the reasons she wanted to make sure that she showed you guys this, which is really, really good. I mean, amazing, amazing. Is because when the numbers are bigger, it's just so much. You've already got P. So we'll just continue to work with it and manipulate it to find your 2 additional points. And the reason why it's the absolute value is you'll go to the right of the focus that many movements, and you'll go to the left of the focus that many movements. It's just on this particular graph, since it's going by increments of 1, it's very difficult to graph 1/4 and 1/2. Does that make sense?
It does.
Okay. So on number 10, you're kind of looking at almost the same thing.
Is it like the opposite?
Yes, it is. Absolutely. You're a genius. So you've got -1y. So if I'm looking at my good old derived standard formula of 4py, what is similar is going to be 4p equals -1 and solve for p. Oops. And then I've got p equals -1/4. So my focus is 0, -1/4. So once again, I think I'm going to try to do it in green. And then my directrix is going to be y equals -1/4.
Okay.
And my parabola, and I'll do it Miss Stone's way, is I'm going to go, basically the absolute value of 2 times -1/4, which is going to be 1/2. So I would go here and here. That's probably a little too far, actually, to be honest with you. But it's so hard to draw that little on this. It's probably a little more like that. Can you tell?
Yes, I can.
Okay. So, and then actually it would go gradually out, honestly. Because it's still going to make that same shape.
Yeah.
And you really honestly would be able to see that on your graphing calculator too.
Can you just like plug that into your calculator and see that?
Yeah.
Oh. Okay.
You can't, I mean, you wouldn't be able to determine what the focus and the directrix are, but you would get a general shape of the parabola.
Okay.
Hey, do you have your graphing calculator on you right now?
I do.
Were you in my math lab where I showed the conics feature on the graphing calculator?
I don't think so.
Okay.
I might have come later.
All right. So is it turned on?
Yeah.
Okay. Do you see the apps button?
Hold on.
It's right next to math.
Yes.
Okay, press that.
Okay.
And then application submenu should open up.
Uh-huh.
And press 4 for conics.
Okay.
And now go 4 again for parabola.
What is this?
And then this is the only thing that you're really going to have to make. Look, there's that 4p that you all know and love. So if what you would have to make sure of on this is on number 2, like you've got to make sure that you're putting in the right squared variable. Does that make sense?
How does this? I can't get it to like. Are you supposed to be able to change the numbers?
Yeah, I'm going to show you how to do that in just a minute.
Okay.
But you have to determine between 1 and 2 first.
Okay.
So you see the top one is y minus k squared.
Yes.
Okay, and the second one is x minus h squared. So you have to determine which of your squared variables that you've got. Does that make sense?
Uh-huh.
Okay, so obviously in our case, we have a x squared, so you need to arrow down to 2.
Okay.
And then hit enter.
Okay.
And now you should have a new window that opened up that's asking you what your H and K are, which are your centers.
Okay.
And for our purposes, this is 0, 0,
Okay.
because the center is the origin. And
Is
then
the B
you would
one?
go down to P, and you would put in, like, okay, let's graph this particular one. And you would plug in negative 1 divided by 4. I think you can put 1 divided by 4 here. Yeah, it'll convert to you. Okay? And now hit graph.
Okay.
So it
Wait.
kind of gives you an idea of the shape of the graph and all that. It's not a perfect
Yeah,
by
but it just
stretch
kind
of
of
the
like shows you what it should look like.
Yes.
That's
It's
cool.
not perfect,
Yeah.
but it does give you, you could tell, okay, this is going to go upside down and all of that. But you still have to be able to get P yourself.
Yeah.
But, it would kind of help you. And the only thing that I don't know, that I'm a little questioning and I'm still kind of researching, do you see, I don't know how yours is,
Yeah.
but at the very top, there's a little, there on the very far left,
Uh-huh.
far right, there's a little tiny tick mark almost. Do you have those?
Wait.
Like just very small, that almost look like they're trying to show a point on the
Uh-huh.
x-axis and one on the y,
Yeah.
down kind of in the middle. I'm not absolutely positive, and I'm still been playing with this app a little bit. I'm trying to figure out if this is, yeah, I think it is, honestly. I think that might, no, it's not. I was thinking that might be the focus, but I don't think it is.
Yeah.
I'm still in the midst of playing with all that. But anyway, I just thought that would help you.
Yeah.
It would help you a little bit feel better about the direction of your graph.
Yeah.
Because you're going to have to double check lots of things.
Yeah.
But you can do ellipses, hyperbolas, and parabolas.
That's so cool.
Yeah. It's kind of fun to learn what your calculator can do.
Yeah.
And the other part of it is I feel like it's just one of those things. It's a double check to make you feel confident about how you're graphing it, but you're still having to solve for some of the things that Miss Stone and I want you to know. Like, you still need to solve for P.
Yeah. I like how it has a little like picture of the tiny little graph on this side of like what it should look like.
Yes.
Yeah. That's cool.
So
could we do
I was going to do number 17.
oh yeah.
Hey, Emily.
Hi.
Are you having fun doing conics?
I am. I'm like so stuffed up. My nose. I sound like I don't know. My nose is like.
So bad for you yesterday.
Yeah,
Because I could tell you were sick and you had to take that freaking chemistry test.
know. I was not excited about that. Well, we have to like finish it tomorrow too, so I'm just.
Oh yeah, it's like a 2-day test. That's so.
Yeah.
They were telling me that. That's so.
We should have just like not done it at all. I like.
Exempted the test.
Yeah.
I wish.
Definitely.
I wish I could exempt everything.
Me
Wait,
too.
did you do your presentation sick?
Well, like I don't know. I've been kind of like on and off, like not feeling 100% like for like a week, but it's fine. I think it's because I haven't gotten enough sleep and stuff.
Yeah. Did you like present Mr. Baker's class?
I did, but we didn't finish. We talked for so long. I was like, I'm so sorry.
Was he mad?
He wasn't mad, I don't think. No. He seemed fine with it, but he did yawn like 7 times during our presentation. I was like, I'm sorry, this is so boring.
No way. Oh, I bet it was good.
I hope so.
I'm sorry you're sick.
Yeah, that's a bummer.
It's fine.
All right, for number 17, once again, we're giving you problems where the vertex is at the origin.
Uh-huh.
So for the focus, you want to look at what position that the coordinate, I guess this is the only thing I can say, like which one has a value in it. In this case, it's going to be the y. So that tells us that the x is going to be the squared variable, because remember how I was saying earlier, the focus, if the variable, I don't even know, if the variable, oh look, it locked up again.
Oh no.
So annoying.
It's just like hard for me to like picture like which ones to use or like which place to put it, like X and Y.
I know.
It just confuses me so much.
I know, sweetheart. And I'm trying to make it clear if I possibly can. Let's see. I'm thinking of all the ways that I possibly could put it. If the focus, in our case, it's a little harder to determine when the center is not the origin, but since we're blessed and the center is the origin, how Miss Stone said, the axis of symmetry, the variable, that one variable kind of stays the same. The one coordinate stays the same. Well, in this case, that's the x coordinate.
Yeah.
So the focus is in the y. So that pretty much tells us that P equals -5. Okay. Because remember how the focus is is that y coordinate? Yeah. Well, it also would tell us that the directrix is y equals +5 in this case, since the focus is -5. But the good news is, once you've determined, okay, where is the coordinate for the P? It's in the y position. So that's telling us that I'm going to write x squared equals 4py. And what is P? It's -5. So it's x squared equals 4 times -5. And of course, it's going to quit writing. Times y. You can see where I wrote that over here too. So the answer is x squared. And then it's going to quit and lock up on me again.
Is it 20y?
It's -20y.
-20y.
Because the focus is -5.
Okay.
All right. Now let's just say, for instance, that it said the focus was -50. Then it would be y squared equals -20x. Okay. Does that make sense?
Yeah.
Okay. The system locked up. So as much as I would love to write something to give you a message on that, it's locked up.
You're fine. That makes sense. So it's just like whatever number for your focus is the opposite number, that's the 0 in that little those points, is going to be the number that's squared. Or the
yes, that's it. So I guess, yeah. So yes, that is it. Absolutely.
Okay. All right.
So let's.
Oh my goodness, somebody's alarm is going off in my house.
Huh?
Somebody's alarm is going off in my house.
Oh Lord. Time to do something.
Yeah.
All right. So.
Oh wait.
Do you have all of 8.2 done? Maybe what we should do is you should pretend like you don't have it done, and we'll run through some of these. And you could just do it on a separate sheet of paper and let's talk through it.
Yeah, I did I didn't do number 2, really.
Okay, let's do number 2 then.
Okay. Like I started it, but I didn't really, I don't know, like we learned this so long ago that like everything just kind of left my brain with like all the other conic stuff that we learned.
Yes.
So I was just like, it's all gone.
Well, yeah, and trying to keep it, these are things that have lots of moving parts, and trying to keep each one together can be a little confusing. So, but once again, this is the derived formula, that x squared equals 4py. That is true of every parabola.
Okay.
So that's your standard form. So, you know, good old Miss Sparks, I have to rewrite the formula to make sure that my squared variable's on the left so I can make sure that I'm comparing, you know, everything. My dog, your dog was barking, my dog is snoring.
Oh, that's so cute.
He is crashed out.
Oh,
Conics are not very exciting to him, apparently.
yeah. Me neither.
Okay. So what is similar in this equation to this equation?
Do you is it like the same as before where you set -5/3 equal to 4p?
That's it. You're a genius.
Yes.
So now we're solving for p.
Yeah.
So to do that, you have to divide both sides by 4. And everybody loves a good old complex fraction. So that's going to give us 5/3 divided by 4, which is the same as -5/3 times 1/4.
Yes.
Because you keep flip change. So that's going to be -5/12. And that's such an easy thing to graph, that particular number. Not.
Oh, I thought you were being serious. I was like, really?
No, that's terrible. And, you know, especially on this particular graph, it's terrible. Oh my gosh. But just to point out a few things here, my squared variable is an x. So my focus is going to be in my y. And my directrix is going to be y equals, and it's the opposite of -5/12. So it's a +5/12, like that, which I'm just going to go ahead and round up. Please, Jesus, help me. And just say that the directrix is roughly around 1/2, you know,
Yeah.
hopefully. Does that make sense? Just
Yeah.
because it's so hard to graph 5/12. It's close to 1/2.
It's close enough. Okay, so the directrix is y. Just gonna guess where that goes.
And so now what you would do is multiply 2 times your -5/12, because that's 2 times p, the absolute value, right? To find your additional 2 points.
Yes.
So I'm going to have -10 or +10/12 because it's the absolute value. My bad.
That's a weird number.
Oh, I know. That's even more fun to graph, which basically is 5/6, which is real close to 1. Yay! I'm going to look. So I'm going to go 5/6 of a unit away from the focus for my other 2 points.
Okay.
There. And there.
Is this one opening down?
Yes, it is. Because your focus kind of directs how you do that. Did you see my 3 points? That's my vertex and my 2
Okay.
2 points that I got using the absolute value of 2p. I was going to show you all of that before I actually graphed it because it will be difficult. Do you see them?
Yes.
And you understand where I got everything?
I do, yes.
Okay. And you know what? Her way is way easier to do it on this because it's not that parent graph with those pretty numbers.
Yeah.
I mean, this would have been, I mean, can you imagine plugging in X to this?
That would be crazy.
Yeah. So that way, this 2p way is way easier with funky fraction numbers like we have.
Yeah.
Let's take a look at number 3. Did you do number 3?
Yeah, I did all the rest of them, but we can do it again.
Okay. Well, the reason why I say that is because we've got the y squared variable is there.
Oh, I see.
And so I just wanted to make sure that we were doing one other one to kind of make sure that you know, that we got the 4p and all that other stuff. So on this one, the standard formula would look like this, right?
Yes.
So I'm going to rewrite this so that everything aligns itself properly. And how they look alike is this number and this should be equal to each other. I don't know. Does that help you to see it that way?
It does.
Okay, good.
Kind of like cross them out and stuff.
Yes. So then to solve for P, I've got to divide both sides by 4. And now I've got negative 1/2 equals P. But the key thing here is that it's going to be in my X variable this time.
Yes.
Because it's the Y squared. So essentially, I guess you could just say that the focus is always going to be on the same side as that single, like where the P is to begin with. Does that?
Oh, yeah. She actually did say something like that. She was like, it's going to be like with the one that it's like next to.
Yes. There you go. So negative 1/2 is going to be our focus. So there she is. And then our directrix is going to be X equals a positive 1/2 because the directrix always runs perpendicular to the axis of symmetry, which in this case, instead of it being the y-axis, it's going to be the x-axis. And you've got the origin as your center. And then we'll go ahead and do the 2p. The absolute value of 2 times a negative 1/2. This one's a little easier, isn't it? So it's going to be 1. So I'll graph. I'm going to go a distance of 1 on each side, you know, from the focus. And then I can graph it.
That makes sense. Do you think we could do one of the ones on like the very back that has like they give you like a few pieces of information and you have to write the formula?
Absolutely. We can do all of them if you want.
Okay. Can we can we start at number 9 maybe?
Yes. Okay, so the vertex is at the origin, and we just say thank you, Jesus.
Yeah.
And then where is which position in the ordered pair is the focus?
Y.
Y. So that means that we've got an x squared equals 4py situation, correct?
Yeah.
Because it's going to go with the focus is going to be with the single variable. I don't know how better to say it, you know, not the squared one.
Yeah.
It's going to be close to the 4p, I guess is the best way to say it. All right, so all you're going to do here is plug in 4 times the p, which in this case, p equals 1/52. So you'll plug that in. And then it's going to be 4/52, which reduces to x squared equals 1/13.
Yeah.
Why?
Okay.
Can you see that? Yeah. Bless your heart. It's all scrunched up.
No, I can see it. It's good.
Oh, okay, good. All right, let's
So for the next one, it would be y squared.
Good job. Perfect.
Yeah.
Perfect. You're doing great.
I'm glad. So it'd be 4 times 3/4x. Right?
Yes. So you did this?
Yes. Yeah.
So 12/4, which I think it turns out to be 3x.
Yeah.
Yep, that's it.
Okay. That makes sense.
And the thing, when you get down to the directrix, the important thing to remember is to take the opposite. So
Okay.
if the directrix is x equals negative 1/8, then P is going to be a positive 1/8.
Yeah, that makes sense.
And this is going to be a y squared one.
Yes.
4 times a positive 1/8 x. Which then it turns out to be 1/2 x. Y squared equals 1/2 x.
Okay. And for the other one, it would be x squared.
Yes.
And then whatever 4 times that is. 4.
So we 1/3.
1/3. Y. And
Yes.
then,
Well, yes, 1/3 y.
And then y squared for number 13. Y squared equals whatever 2x. Is that right?
Yes.
2x.
That's it.
And
And then the last one,
4 divided by 1/4 x.
that's it. That's perfect. And it's going to be y squared.
Y squared. Yes.
So that's it.
Okay. That helps a lot.
Good. So you feel more confident about it?
Yes, I do. I think I just needed like a reminder on how to do it because I like literally forgot all the.
Well, you know what? You know what was really good, because I had forgotten all about the 2p thing.
Yeah.
You remembered that. So it came back to you well.
Yeah.
You did really good. Really, really good.
That's good.
You're very smart.
Oh.
So,
Oh wait. There's like.
was there other questions?
Let me see. For when we turn in our packet of work, does she want all the notes filled out too? Because I think I might have missed a section of the notes.
Yes, she does. So what did you miss?
Trying to find it.
Tell me which one, and I will try to bring it up, or at least tell you what to fill in.
Oh, it's for the hyperbolas.
Yes, ma'am.
The second page says like horizontal hyperbola and then vertical hyperbola, and then like it goes down and there's like a blank and it says is the blank, and then it says blank is the distance from the blank to the blank. So I don't really know like.
Oh, okay. I got you. I got you.
I think I was like still finishing other problems when somebody was going over it, so I like missed what they were doing.
Okay. I'm still trying to find my notes, and I'm sorry.
You're good. You're good.
Okay, I got it. Is it okay if I just tell you what it is? Because I'm not sure. I'm not absolutely sure if I have that as a document, but
yeah, just yeah.
Did you get the graphs of the horizontal hyperbola, like what the standard equation is?
Yeah, I got the equations. It was just like the little like pieces of like fill in at the bottom.
All right, let me see if. Look.
Ooh.
Yay. Mine's a little different, so I'm going to try to see if I can find it.
Okay.
There you go. Is that what you're missing?
Can
you see it or no?
Yes.
Let me see.
But
this might bring it up a little better. I don't know. Hopefully it will.
Okay.
Maybe not. It's trying. Technology is a beautiful thing and a sad thing.
Yeah, I agree.
Can you see it okay?
Yes. Since we're just doing the center as 0, 0, can the H and K just be 0, 0?
Well, what you could do just to make sure that if she's checking all the notes, what I would write down if I were you is I would write down the H and K. And the only reason that I'm saying that, and then what I would do is write down H and K here, just like it is here. And then over here, I would write this.
Okay.
Just as kind of a note for you for this year. And the only reason I say that is because next year that you won't be dealing with stuff that's the center. So I guess what I want you to do is really familiarize yourself with what it's actually going to be. Does that make sense?
Yeah, it does.
Okay. And A is the distance from the center to the vertice, and B is the distance from the center to the co-vertices.
Okay, I'm gonna write down the equations at the top because I just got the ones that were for 0, 0.
Okay. And those are kind of important. Just, you know how you said it's difficult, like we learned a lot of stuff about conic sections and it's kind of hard to keep them all together. I feel like the more that you guys understand that H and K is always the center, and X is always, H is always kind of, it's always goes with the X and K always goes with the Y. It's just it's gonna help you every time you work with a conic, because no matter what, whether it's a hyperbola, a circle, an ellipse, or a parabola, H and K are always the center.
Okay.
And so the more times I think you get that repeated to you, the better it will be for you in the future. Does that make sense?
Yeah, because next year we're going to be like adding more to this.
Yes, ma'am.
Okay.
And so I feel like if you can write down that H and K is the center, and then for our purposes this year, know that we're always making that 0, 0 because of all the moving parts, because trying to remember that you've got the vertices, the co-vertices, and then there's the focus or the foci, depending upon, obviously it's foci when you're dealing with hyperbolas and ellipses, and it's focus when you're dealing with the parabola. Just trying to learn all of those things and keep them together.
Yeah.
Is there any questions about the hyperbola or the ellipse?
I don't think so. I'm just making sure that I have everything filled out and I understand it. Okay, I did that. Oh wait, what is that? For the parabolas worksheet, do you have that one?
Say that again.
The parabolas worksheet, do you have that worksheet?
Yeah, are you talking about the Cornell notes or the worksheet?
Oh, the notes, sorry.
Oh, no problem. Yes, I do have that one.
There was one section up here that I missed for some reason. I don't know. I think some of it she was saying that we didn't have to fill in, but I just want to have it all just in case.
Yes. I might actually open the Google slide because I think it's filled in there perfectly.
Okay. Got that.
Do you have all of that? And can you see it?
Yes. Yes. I think it was just the back page.
Okay. I'm just going to go through each slide and make sure that you have each one. You have that?
Wait. Yes.
Okay.
Yes.
This?
Yeah. Yes, I did that. Yeah.
Okay. This?
Oh, that was the one that I didn't get.
Okay.
So P.
And she may have added, might be where she added that 2p thing. And I obviously didn't put it down on mine, so.
I'm not really sure.
Do you know where she did that?
The I don't really. She just kind of added it when we were doing the graphs, the practice graphs. She kind of just added it at the bottom.
Yeah, I think she was giving me a hard time, but I was like, "Hey, Kuda came up with the problems that we had to do," and she was like, "You can't do a T chart with those."
Oh my goodness.
It was funny.
Oh my goodness.
Because she's right, though. I mean, though, it's yay.
Yeah. Okay, I think I have everything else. Well, wait.
Well, you double check everything, and I'll wait.
Okay, for the ellipses. Well, actually, I think this is just. I don't know. The ellipses one. I don't have the standard form for like the center at like H and K.
Okay.
But I don't really think she told us to write that down. But just in case, I want to have it filled out.
Okay. And that was ellipses?
Yes. I've like looked through these worksheets so many times, like making sure I have it all.
Yeah. Well, good for you. I'm just going to go, you've got all of that, correct?
Yes.
And this?
Yes.
Is this what you needed?
Yes, it's just the bottom part of this one.
Yeah. And once again, I guess I had mine, and just different teachers asking different things of students. I guess I had mine write it down just because I want you all, as much as you possibly can, to see that H and K.
Yeah.
And also significantly, and I pointed this out, is to notice that in the original derived equation, that it's always X minus H and Y minus K. So next year, like when you see that minus H or that minus K, to know that if it's X minus 2 and Y minus 3, that the center is 2 and 3. But if it's X plus 2 and Y plus 3, then it's negative 2, negative 3. Does that make sense? Because like you're pulling it out, it's kind of, if you will, kind of the opposite, because the original equation has the minus in it. And so that's why I'm trying as much as I possibly can to make sure that you guys see it.
Yeah. That makes sense. Okay, I think that's everything. I think I got everything now.
Okay, good.
Thank you for your help. That helped a lot.
Oh, no problem. No problem. You really knew a lot of it. You just needed your confidence boosted. That's all.
Yeah.
You did great.
Thank you.
Have a good day. Hope you feel better, honey.
Thank you.
Bye-bye.
Mom.
Yes.